right, welcome to Lecture 11. This is the material that you will find in Chapter 3, Section 4 of your book. We will do three main things today, and the last thing has a lot of different parts, so I'll probably break that into pretty short little lecture videos near the end. First of all, I just want to talk about slope-intercept form. Okay, before we do that, here's just a little motivation. Let's look at line 1 that goes through those 2 points, line 2 that goes through the next 2, and line 3 that goes through those 2. I want us to plot each pair of points and then draw the line that goes through them. So for line 1, there's the point 0, 0. There is the point 3, 2. And there's the line in between them. So line 1 is the red line. For line 2, there's the point 0, 3. There's the point 6, 7, and there is line 2. So line 2 is blue. Line 3 goes through 0, negative 2, and 3, 0. So there is line 3. Now what do you notice about the lines? Well, they really look like they're parallel. Now, they might just be close to parallel, but not actually parallel. How could we check to make sure that they are actually parallel? Well, we would take the slope between those 2 points. We have 2 points, so we can find the slope. We'll take y minus y, so we have 2 minus 0, divided by x minus x, so divided by 3 minus 0, and we get 2/3. So the slope of the red line is 2/3. Okay, for line number 2, we take 7 minus 3, y minus y, divided by 6 minus 0, which is 4/6, but that simplifies to give me 2/3. Okay, for the last line, I'd have 0 minus a negative 2 divided by 3 minus 0, which also gives me 2/3. So they all have a slope of 2/3, so they all are parallel. Now just take it on faith that these are the equations. I'll show you how to do that. Within 10 minutes you'll be doing this in your sleep, but just for now, pretend that you don't know and we'll just start from scratch. So look at the equation of the red line, which is 2/3 x, the blue line, which is y equals 2/3 x plus 3, and the green line, which is y equals 2/3 x minus 2. Look at just the equations. What do you notice about those equations? Okay, the first thing that you might notice that every single one of them has a 2/3 in front of the x. Now what's special about 2/3? What is 2/3? 2/3 is the slope, so all of them have 2/3 in front of the x. And then the other number is where that line happens to cross the y-axis. You can see that in 2 places. You can look at the graph and notice that the red line crosses at 0, and there is no number after 2/3 x. That the blue line crosses at 3, and in the equation there's a 3 after the 2/3 x. And the green line crosses at negative 2, and there's a negative 2 in the equation after 2/3 x. Or you could notice in the ordered pairs that we were first given, we have the point 0, 0, 0, 3, and 0, negative 2. So we were actually given the y-intercept. Okay, writing the equation so that you can easily see the slope and the y-intercept is called putting the equation in slope-intercept form. So we find slope-intercept form by solving for y, and we get y equals mx plus b. So on the previous slide, we had y equals 2/3 x, because all those lines had a slope of 2/3. They all had 2/3 in front of the x, and then they just had different b's because they crossed the graph at different points on the y-axis. So to find slope-intercept form, the first thing we'll do is we'll solve for y. The number that after we solve for y, not before we solve for y, but after we solve for y, the number in front of the x is the slope. And then the constant is b, which is the y part of the y-intercept. Okay, so let's put these guys in slope-intercept form. I want to then find the slope and the y-intercept, and then I want to graph it. So there's 3 parts to these problems. So for the first one, put it in slope-intercept form. First thing I need to do is solve for y. I want y by itself. So I subtract 2x from both sides. And again, like I told you in lecture 10, you could write 4 minus 2x, but life's going to be a little easier for you if you'll write it as negative 2x plus 4, because it will get us to slope-intercept form quicker. Now I don't have y by itself yet. I want to divide by negative 5. And again, you could put the whole right-hand side of the equation over negative 5, but your life will be a little bit easier if you'll just do it a piece at a time. So we'll get y equals, so negative 5y divided by negative 5 gives me y. The negative 2x divided by negative 5. The negative divided by negative is positive. 2 divided by 5 gives me 2/5. And then I've got my x. And then 4 divided by negative 5 gives me negative 4/5. So I've done the first part. I've got my equation in slope-intercept form because I have y all by itself. Now I need to find the slope and the y-intercept and then graph it. So my slope for this equation is just the number in front of the x. It's 2/5. My y-intercept is negative 4/5. So I've identified the slope and the y-intercept, and now I want to put them on the graph. Now remember, when you're graphing something, what do you put on the graph first? Do you put on the slope first, or do you put on the y-intercept, the point? Always put on the point first. Now, negative 4/5, where is that? Well, it's about right there. It's almost negative 1. Okay, and then we're going to go up 2 over 5, up 2 over 5, or down 2 back 5, and there's my line. Now I want to have you pause the video and do this next one on your own. All right, now that you've got it, remember we want to get y by itself. So we subtract 3x from both sides. Now y still isn't by itself. Some people will stop here, but we need y by itself, not negative y. Multiply both sides by negative 1. So we get y equals 3x minus 5. What is my slope? My slope is 3, which is the same as 3 over 1. You're welcome to write it as 3, but once we go to graph, it's going to be a little easier to think of it as 3 over 1. My y-intercept is negative 5. Okay, first thing I put on the graph is where it crosses the y-axis, not the x-axis, but the y-axis. Crosses at negative 5, and then I go up 3 over 1. The only problem that I see with people writing the slope is just 3 is sometimes they go up 3, but then they forget to go over, and so they end up with a vertical line. So remember, up 3 over 1, up 3 over 1, or down 3 back 1, and there's our line. Okay, last two, and these ones are a little bit different. Put in slope-intercept form, find the slope and the y-intercept, and graph. So for this first one, I want to get y by itself, so I divide both sides by negative 8, and I get y equals negative 1/4. Now what is the slope? There isn't an x. Well, because there isn't an x, it's almost like there's 0 x's. So my slope is 0, and my y-intercept is negative 1/4. Don't think your slope is negative 1/4 because it's not in front of an x. The slope is always the number in front of the x. So if there isn't an x there, it's like 0 is in front of the x. So I cross my y-axis at negative 1/4. My slope is 0, and I've got a horizontal line, which I should have known because as soon as I only have one variable, I know it's either horizontal or vertical. If it's a y, it's a horizontal. If it's an x, it's a vertical. Which brings us to our next problem. What do we do with x plus 6 equals 8? Okay, well, first of all, we'll simplify. We'll subtract 6 from both sides. We get x equals 2. There is no slope-intercept form. There's no way of getting y by itself. So whenever you've got a horizontal and vertical line, it's almost like you're in a special case. You can kind of just treat that one, solve it using your intuition. So x equals 2 is a vertical line at 2. And those guys are done. That's as much as we can possibly do.